there, ROS developers, and welcome to a new open class. Today we are in open class number 157, and we are going to be talking about ROS2, and more specifically about ROS2 topics. And we are going to be doing that using C++. Yeah, so today we are going back to C++ and ROS2. So yeah, if you are interested in learning about one of the most important things in the ROS and ROS2 ecosystem, which are topics, and how to deal with them, how to create programs that interact, that use topics using C++, then stay here in this open class with me. So yeah, welcome everybody. Let me know as always, please, in the chat if everything is fine, sound is fine, image is fine. I'm going to switch to my computer screen right now. There we go. All right. Let me log in here. Okay. Yeah, let me go to the open class so that I can get the chat here and see if you are saying anything. Okay, no messages so far. All right, then yeah, so as always, yeah, we are going to start by getting today's rosject. Yeah, so we need to get the rosject for today's open class so that you are going to get all the codes and everything that we are going to be using. So in order to do this, very simple, all you have to do is to click here in this button that you have right above the chat, which says fork, and open the class rosject. So yeah, I'm going to click here myself. So all of you, please click here as well. And this is going to create a copy of this rosject into your account. So you are going to have this copy forever. So you will be able to reopen this rosject whenever you want. If you want to review it, to keep working on it, etc., you are going to have it there in your account forever. Okay. And yeah, and also it's going to automatically bring you here to the rosject page. As you can see, this is what it's loading for me right now. It might take some seconds to fully load. I can see here in the chat, Ahmed, hello there. Yeah, then here in the right side of the screen, you have the streaming area with the chat, the live stream here, so that you can see what I am doing and so on. Hello to Rick Hernandez also, Florencio. Hello everybody. So yeah, as you come, please keep all of you get the rosject, today's rosject, and open it. Yeah. Then when it's completely loaded, you are going to see, like here in my case, that the notebook is going to be automatically opened. Yeah. So so yeah, let me know if you have been able to copy the rosject properly. If it's been loaded, not yet, it is still loading. Yeah, I'm going to wait for all of you to have the rosject open so that we can keep moving together. All right. Then yeah, so today as I already said in the introduction, we are going to be talking about ROS2 topics using C++ code. Okay. But today I'm going to do a live class, an open class, which is a bit different. Yeah, so instead of putting here in the notebook a bunch of theory and so on, I have rather placed a couple of exercises. Yeah, and then we are going to solve these two exercises together. Yeah, we are going to be doing it step by step, and we have all the codes here so that we are going to be able to check them, to review line by line what they are doing. Yeah, but I wanted to try to learn about ROS2 topics. Yeah, using a couple of exercises. Okay. Ricardo Tellez is also here. Hello. So yeah, let me know. Have you been able to get and to load the rosject? Yes, no? So once it's loaded, you should see something very similar to what I have here with the notebook opened. Okay, and the notebook is important that you have it, because it contains all the instructions, codes, and everything that I'm going to be doing. You have it also here. Yeah, so in case that you miss some command or something that I do, you are going to also find it here in the notebook. Ahmed says yes, so rosject has been loaded for him. Okay, also for Rick. Perfect. I see that everything is going fine then. All right, then the very first thing that we are going to do is to launch a simulation. Yeah, so for this we need to have a new terminal, a new shell. Then in order to open a new shell, all you have to do is to click in this icon that is highlighted here in red. Yeah, you are going to find this icon here in the bottom menu here. It's the first icon here, starting from the left. Yeah, then if you click here, this is going to open here in the rosject, as you can see, an empty, a blank shell. All right, then this is a regular Linux shell, so you can type any type of Linux command. So in this case, we are going to run these two commands. Yeah, first a cd command. We are going to move to a specific folder, which is this Robotics ROS2 folder. Yeah. Then, as you can see here at the right side of the cell, you have this icon. Yeah, you can use this in order to directly copy a specific command that appears here in the notebook. Yeah. So, for instance, in this case, if you click here in this first command at the right side, yeah, this is going to copy the command, as you can see, and then you can come directly here to the shell and paste it with directly like this, or with Control-V, with the shortcut, however you prefer. Okay? Then, yeah, so once you are here in the path, then, as you can see, what we are going to do is to execute a bash script. Yeah? Then let's also copy this second command, yeah, from the notebook, and then paste it here into the shell and press enter in order to execute it. Okay. Then what is this going to do? Well, this bash script basically contains some commands. We can have a quick look now. But what it is doing is to start a gazebo simulation. Yeah. So here, as you can see, it's loading some processes, GC server, GZ client. Yeah. Then after some seconds, as you can see, the gazebo window should pop up and should display the simulation. Yeah. The simulation that we are expecting is shown here. Okay, so you should get something similar to this. Then let me go back to my gazebo screen, and as you can see, I get this same simulation. Yeah, it's you have here the robot in the center. I can zoom in to show you. Yeah, here we have the robot, which is an MP400 from Robotics. Yeah, and it's in this environment with a sphere here in front of it. Yeah, and it's in this environment. So yeah, you should have a simulation like this one. Okay, it might happen, just so that you know, it might happen that that gazebo doesn't load properly. Yeah, sometimes there are some bugs the first time that you launch the simulation. So in case that your simulation doesn't load, for instance, one thing that could happen to you is that the simulation loads, let's say the environment loads, but the robot doesn't spawn. Yeah, this is a bug that sometimes happens in Gazebo. I don't know if this is your case. Have you been able to load the simulation properly? Do you have it like me? Or do you have any issue? Your robot is not appearing, everything is fine? Florencio says yes. So I suppose that your simulation loaded properly, Florencio? Yeah. So for the rest, Rick, Ahmed, have you been able to load? Yeah, Ahmed says yes. Also Rick, also Hassan. Okay, perfect. Then everything worked in the first try. All right. In any case, if for whatever the reason your simulation doesn't load properly, all you have to do is to just relaunch the command, okay? Then, if we are all properly set up, then we can keep going, okay? Then, yeah, so as a requirement for this course, I have added here at the top of the notebook this C++ for robotics course. Yeah, you can click here, and this is going to bring you to our course in the academy, which is free. So you can do this whole course for free. Very interesting course where you are going to learn all the basic but most essential topics from for programming in C++. Yeah, like for instance, conditional statements, loops, how to create functions, how to work with arrays and pointers, C++ classes, etc. Okay, so here you are going to find all the basic C++ stuff for free, and always focused on robotics. Yeah. Then today we are going to be using C++ in order to create our ROS2 programs. So that's why I added the link to this course here, okay? I'm not going to be explaining C++ concepts because it's not the focus of this class. Yeah, the focus of this class is that we know how to work with topics in ROS2 using C++. Yeah, but not to teach C++ programming. So in case that you want to get some extra knowledge, yeah, maybe you don't know a lot about C++ programming, so then you have this course here that you can check for free, and it's going to give you a good foundation on C++ programming. All right. Okay, then yeah. So having started the simulation, let's go with the focus, the main point of the class, which is topics. Topics in ROS2 and in C++. Yeah. So the idea of topics, yeah, it's quite similar to ROS1. I don't know if you have experience with ROS1. Maybe you already have experience with ROS2. But this idea of topic is something that can be, it's very similar, both in ROS1 and in ROS2, okay? Then ROS2 is based on nodes. Yeah, here I have added a graph, which is pretty straightforward and easy to understand, yeah, which I have taken from the official documentation. And here we can see that we have a couple of nodes. Yeah, we have a node 1 here, let's say a node 2 here. And between them, we have here this topic thing, okay? So I can see here Thomas, hello Thomas. Zemping is sharing here an error message. Yeah, don't worry about the error messages. So here I am also getting some error messages, as you can see in the shell. The important thing is that the simulation loads properly, like this, okay? That you have the gazebo simulation loaded with the robot. If you have this loaded, don't worry about the red message, the red error messages that appear here in the shell, okay? Then, yeah, so does somebody, can somebody explain me what is a topic in your own words? Let's see if you have already an idea or not at all. How would you define a topic in one sentence? Let's see. Yeah, maybe you need to give it a you need to think a little bit about how to elaborate the sentence. Okay, here we have Ahmed. It's like variable to read and write, but in ROS. Okay. Okay, yeah. I think that we can use some things of this definition. Yeah, so in my case, let's say that I like to define a topic, to think of a topic as a pipe, yeah, because it's a kind of pipe where you can either put information or get information from, which is the same than saying that you can either write information to or read information from. Yeah. Then ROS2 is based in nodes. We can think of a node, of a ROS2 node. Maybe we can think as a program, a ROS2 program. Okay. Then nodes can connect between them, can communicate between them using topics. Yeah, these topics are these pipes, as I was saying a moment ago, these channels where a node can either put information to or can read information from. Yeah, then in this case, in this graph, you can see that this node here is writing information into the topic. Yeah, and then this information, which is flowing through the topic, is then read by another node. Okay? And like this, the both nodes communicate. Okay? Then node 1, for instance, can be a sensor of the robot. Yeah? So node 1 could be, for instance, the laser of a robot, right? And node 2, for instance, can be a program that you use, a program that you create. You create a program that reads the information from the laser of the robot and then does something with this information. It processes this information, whatever. Yeah. Then, like Ahmed said, in order to write information into a topic, you need what is known as a publisher node. Yeah? If you want to write information into a topic, you need to create a publisher node. Yeah? And in the other hand, if you want to read information from a topic, you need to create a subscriber node. Okay? Yeah? So you can write information into a topic or read information from a topic. Yeah? The topic is just the container of this information. Yeah? It's the pipe through which this information flows. Yeah? Then if you want to write information into a topic, you have to create a publisher node. And if you want to read the information from this topic, you have to create a subscriber node. Okay? Then, okay, so how do I create a publisher node? All right. So the most common way to create a publisher node is to create a script, a program. Yeah, you can create a Python program, a C++ program. In this case, we are going to see how to create a publisher node using C++. Okay. Then here I have defined an exercise which is going to put this into practice, and at the same time we are going to be communicating with the robot in our simulation. Yeah, this is why we launched the simulation at the beginning, because we are going to be using this simulated robot as an example. Yeah. Then what are we going to do in this exercise? Well, it says, first of all, create a new package named topic publisher package. Now, inside this package, create a new C++ script named like this, moverobot.cpp. Now, inside this new CPP script, create a publisher node that publishes data to this topic. To this topic, which is named CMD Bell. Yeah? Then also we are going to create a launch file named like this in order to start our publisher node. All right? Then we are going to have to do some modifications to this cmakelist.txt file for compilation. And finally, we will compile and launch our program. Yeah? Then at the end, we should get something like this, which is we should see the robot moving, okay? As you can see right now, the robot is quiet, it's not moving, yeah? So somehow our publisher node is going to publish in this CMD Bell topic, yeah? And what does this CMD Bell topic? Well, basically, this topic is used in order to send velocity commands to a robot. Okay? So we are going to be publishing messages into this CMD Bell topic, and the robot is listening to this topic. Yeah, it's subscribed to this topic. Then whatever messages I publish here are going to be read by the robot, and this is going to be converted into movement. Yeah? So here we have some notes for this exercise. Yeah, like first of all, we have that the command bell topic is the topic used to move the robot. Okay? In most of the robots, you are going to find a topic which is named command bell or something plus command bell. Okay? Then always that you see this topic, it means that you can use it in order to send velocities to the robot, yeah, to move the robot. Then the type of message that this topic uses is a twist message, okay? Each topic has a type of message associated to it, yeah? So each topic can contain different type of information, right? And this information, the information that the topic contains, is going to be defined by the type of message that this topic uses, right? Then we have some commands in order to check the structure of this specific message that we are going to be testing in a moment, yeah? Then here we have a brief explanation of the types of velocities that we can send to the robot. So summarizing, in our case, this Robotics MP400 robot uses a differential drive plugin, okay? Which means that can be moved forward in the x-axis and can be rotated on its own z-axis, okay? So what does this mean? This means that we can only send to the robot linear velocities in the x-axis. Yeah, let me put this a bit bigger here and show you the axis. Yeah, here I can show the axis. Yeah, so this red axis is the linear x, right? Then I can send velocities in the linear x-axis, not in the z, which is the blue, or the y, which is the green. Yeah? And also, besides the linear x, I can also send velocities here in the angular z, yeah, which is this blue axis that I can see here, yeah, which is going to make the robot rotate like this on its own z-axis. Okay? So these are the two movements that this robot can do. Rotate on its own z-axis, like I'm doing right now, manually, or move in its x-axis, which is this. Okay? Yeah, so far so good. Are you following? Questions? Yes, no? Okay, so don't worry, because this first exercise, Rick says that he's following, great. So this first exercise, we are going to do it together, okay, step by step. Then let's go for it. So first thing first, yeah. So we have to start by creating a new package, okay? Then let's create our new package, yeah? So in order to create a new ROS package, always you have to be in the SRC folder of your workspace, okay? These are all basic concepts that I'm going over, yeah? Then, yeah, so first thing is to copy and paste this command in order to move to the SRC folder of my ROS2 workspace, okay? Then next is to execute this command that I have here, ROS2 package create, yeah? This command is going to create my new ROS2 package. So I'm going to also select this command and run it here, okay? Execute it, there we go. Okay. Now, as you can see, yeah, let me put this a little bit bigger. Yeah, so now I have created my new package. For instance, if you execute the ls command, you are going to see that the new package has been created here, topic publisher package, okay? Also, you can visualize it using the IDE, yeah? You can open the IDE by clicking on this second button, the one which is side by side with the shell button down here. This second one, which says code editor, you can click on this, and this is going to load the IDE. Yeah, the IDE, basically it's the integrated development environment, which is going to allow you to visualize everything like this, with a graphical interface, yeah, which is always better and easier to understand. So in this case, we are working inside this ROS2 workspace, and we have created this topic publisher package right now, yeah? Then, in order to create the package, let me put it here again, I have used this command, ROS2 package create, topic publisher package, okay, this is the name of the package. Here I specify the type of package that I want to generate. In this case, I have generated an amend CMake package, okay? If I wanted to create a Python package, instead of amend CMake, I would specify amend Python, for instance, yeah? So this indicates that I am creating a CMake package. Yeah, and finally at the end, I specify the dependencies of my package, which in this case are two, RCL CPP and geometry messages. Yeah, so can you tell me why? For instance, why I need this dependency, RCL CPP? Does somebody know? Why do I need to add this dependency? Because we are going to work with C++. Exactly. Very well, Carlos. Yeah. So because we are going to be working with CPP, we are going to be generating CPP scripts, then we need to import the RCL CPP client library. Okay, this is a client library and basically allows me to create C++ programs for ROS2. Yeah? And what about this second? Why do I need this one? Does somebody know? Why do I need geometry messages? No? Yeah, so this one, these geometry messages, okay, because you're going to use the CMD and twist commands. Okay, very well. Yeah. So, okay, let's do some research at this point, okay? So my exercise wants me to publish into the common belt topic, right? Then how can I get a list of all the topics available right now? Very simple. I use the ROS2 topic list command. Yeah. If I run this topic, ROS2 topic list, this is going to list all the topics that are available right now. So let me run this command myself here. ROS2 topic list. Okay, so these are all the topics that I have available right now, that my simulation, that my robot is providing. Yeah. And I can see here the common bell topic, which is the one that I'm going to be publishing to, right? Then how can I get more information about this specific topic? Well, again, I use the ROS2 topic command. Yeah. Always that you want to work with topics from the shell, using the command line tools, you're going to use the ROS2 topic structure. Yeah. ROS2 topic something. So ROS2 topic list is going to give you the list of all the topics. Now, if you want information about a specific topic, you can use ROS2 topic info. Okay. And then you specify the name of the topic that you want to get information from. Yeah. So ROS2 topic info command bell is going to give me some additional information about this command bell topic. So let me run this command. Yeah. And then here it says, first of all, we have the type. Yeah. So this indicates the type of message that this topic uses. Yeah, the type of information that this topic contains. Okay. Then this is the type. Yeah, this twist, this is the type. Yeah. And this geometry messages is the package that contains this type. Okay. So if I want to publish information into this topic, I'm going to have to publish information using this message, the twist message, right? Therefore, if I want to use this twist message, I'm going to need to import to have access to the package that contains this message. In this case, this package is geometry messages. Yeah? This is why when creating my package, I specified these geometry messages as a dependency for my package. Okay? Yeah? Then here I can see some additional information like the publisher count. How many publishers does this topic have currently? 0. Yeah? So it has no publishers. And how many subscribers has this topic? 1. Yeah? Who do you think is subscribed to this topic? Who do you think is this one subscriber that the common bell topic has? Nobody? Florencio says, the emulation. Well, I assume that you refer to the simulation. Hassan says, the mobile robot. Very well, yeah. So, yeah, both are valid, yeah. So this subscriber is the robot, is the mobile robot, yeah. It's this robot. And in our case, this robot is represented by the simulation, by the gazebo simulation, okay? But yet, the one who is listening, who is subscribed to this topic is the robot, yeah? Because whenever somebody publishes twist messages into this topic, the robot is going to receive these messages and it's going to convert them into velocity. Okay, so very well, very well. All right. Then, okay, just for reference, so if you want to see a complete list of, I'm not going to go over all of them, okay? I'm going to be using some of them, the most important ones, like ROS2 topic list, ROS2 topic info. But if you want to see all the available commands, you can run ROS2 topic -h, okay? Then you are going to see all the available topics and what they do. All right? Okay, then let's continue with our exercise. So we have created our package. Then we are going to create our script. Yeah? So let me go to the IDE, and now here inside the SRC folder, I'm going to create my C++ script. Yeah? So in order to do this easily, you can right-click here in the SRC folder, and then just select New File. Okay? And then you just give a name to the file, which in my case, let me see, it's going to be move_robot.cpp. Okay? So move_robot.cpp. And I click OK, and then the file is created. And it's an empty file, right? Because I have just created this file. So the next thing I'm going to do is to put some code inside this file, okay? Now, for the code, don't use this button, okay? Because in some cases, I have seen that there are some bugs when copying code using this the clipboard icon, okay? So for the code, please just go to the cell, select everything, okay? It's very easy. You just select all the code and copy it, yeah? For instance, with Control-C, with the shortcut, or you can right-click and copy. Let me do it again, and copy. Okay, you can right-click and copy, and then once you have copied the code, you come to the script here in the code editor and paste it. Okay? Or, there we go, with the shortcut. Okay? And then you have the C++ code here. All right? Then let's have a quick look here at the code. Let's see what we are doing. It's very simple. So, yeah. So first of all, we can see that we have some includes. Okay? So we are including the RCL CPP header files and the twist message header files. Right? From geometry messages, okay? And also a chrono module here, yeah? Then we are defining here a class, yeah? We have these chrono literals here, but I don't want to go line by line because this is more C++, but basically this line allows you to be able to define times like this, okay? Like with ms or with s for seconds and these things, yeah. But yeah, let's go for the things that really are important. So I am defining here a class, okay, named moveRobot, and this class inherits from the node class, okay. Most of the codes that you are going to be creating, you will see that they are going to inherit from the node class, okay, from RCL CPP. Then we have here in the public attributes, we have here the constructor of our class. Yeah. Now in our constructor is where we are generating our publisher. Yeah. It's right here, as you can see. Yeah. With create publisher. Then when creating a publisher, of course, you need to specify what type of information you are going to be publishing, right? In our case, we have already defined it, that our publisher is going to publish twist messages, okay? So you have to specify this for your publisher. Second, you have to specify to which topic you want to be publishing. In this case, we want to publish into the CMD Bell topic, right? And finally, this is related to quality of service, which is a more advanced concept. So usually for simple programs, you can leave this to 10 or to default values. Okay, so let's not get into this right now. Yeah. But basically, you create the publisher and you specify the type of message to use and the topic to publish this data to. Okay? And second, here I am defining a timer. Okay? As you can see, with create wall timer, and here we are binding a callback. Yeah, which is this timer callback. Timer objects are very used in ROS2. All right. In this case, this timer is going to be executed with this period, 500 milliseconds. Okay. So this timer callback function is going to be executed every 500 milliseconds. Okay. Then what do I have in this timer callback function? Well, here I have it defined. Yeah. So what am I doing here in this function? Well, first of all, I am defining a new message of the type twist. Okay. And then I am giving values to the linear x velocity and to the angular z velocity. See? And we are accessing these values as you can see here from the code, like this. First, I go to the linear, and then I access the x value. And same with angular. First, I get inside the angular, and then in the z. Okay? Then you might be asking, and how do you know this structure? And that's a very good question. So the easiest way to find out the structure of a message is to use the following command: ROS2 interface show. Okay? So for all the commands related to messages, topic messages, you're going to use the ROS2 interface structure. Okay? Then you can also run ROS2 interface with -h to see all the available options. Okay? And show, as you can see, if you have a look at show, it says output the interface definition. Yeah? So we can try this ROS2 interface show, and then we have to specify the path. Yeah? So we have to specify the package that contains the message, which is geometry messages, then the folder that contains it, which is message, and then finally the interface or the message name, which is twist, like this. Okay? And if you run this, you're going to get the structure of the twist message. Yeah? So as you can see, a twist message is composed of two vector 3 messages. Yeah? The first vector 3 is named linear, and it has 3 floats, x, y, and z. And the second vector 3 is named angular, and it contains inside 3 values, x, y, and z. Yeah? So if you want to, the first one, of course, the first vector defines the linear velocities, and the second one defines the angular velocities. So if you want to set the linear velocity in the x-axis, you're going to have to access the linear vector first, and then the x value. Yeah, which is what we are doing here, right? In line 22. And the same for line 23. Okay? Now, let me make this bigger again. Once I have provided some values to my twist message, I publish it, okay? And how do I publish it? Well, from the publisher of object that I have defined in my constructor, remember, I call the publish method. And I provide the message that I have just created. Yeah? So I'm going to publish a twist message with these values. okay? And this message is going to be published every 500 milliseconds because it's being executed using this timer. Yeah? Then finally here I have the definitions of the timer and publisher. And then in the main, down here in the main, I initiate my node and I spin it. Okay? Spin, the spin method is going to keep my node running until I or somebody manually stops the node. Okay? Yeah? Does it make sense? Do you get it? Yes, no? Questions? Do you see the general structure of the code? Florencio, can we write the script using the standard C++ with header file and CPP for the class? Yeah, sure, yes. Yes, I suppose that you refer to creating a header file where you define the class and then another source file where you implement all the methods and everything, right? Yeah. So you can do that for sure. Here everything is done in one single CPP file. Yes. So here I am doing everything in one single CPP file, but you can separate it, of course. Yeah. When you separate it, Florencio, when you separate the header file with all the definitions and then the source file with the implementations, in ROS terms, let's say in ROS2 terms, you would say that you are creating a library, okay, which is known as a library, but also in C++. So yeah, but yeah, you can totally do that. Very good question. All right, so what else? Okay, then next step. We have created our code. Then let's create our launch file, okay? Now, launch files in packages are going to be placed, usually, inside a launch folder, okay? So let's come to our package right now, right-click here in the package folder, and select a new folder. And then we are going to create a new folder named launch, okay? There we go. And inside the launch folder, we are going to create our launch file, which we are going to name move_robot_launch, move_robot.launch.py, okay? As you can see, in ROS2, launch files are by default written in Python, okay? Then, here again, we are going to copy the contents from the notebook, copy and paste into the code editor, okay? Now let's review the contents of the launch file very quickly. It's very simple. So, as you can see, for launch files, we have to return a launch description object, okay? And this launch description object, it contains a node, as you can see, yeah? And for this node, you have to specify which is the executable that you want to run, the name of the executable, and the name of the package that contains this executable, yeah? The name of the package is the package that we have just created, of course, it's topic publisher package, and the executable is the name of the executable that we are going to generate right now, okay? Then finally, this output screen is just redirecting the output of my program to the shell, to the terminal, okay? Then, almost done. We are almost done, okay? So now what we have to do is to generate our executable, right? And where can we do this? Well, it's in the cmakeLists.txt file. Yeah? If you are familiar with C++, Probably you already know about this file, yeah. But basically here is where you are going to put all the rules for compilation, for when you build your package, yeah. Then what we are going to do here, again, is to select the piece of code that you have here in point number 4, copy it, and paste it here at the end of the file, okay? There we go. Then let's have a very quick look at what we are doing here. Yeah, so first of all, here we are adding an executable. Yeah, so we are going to generate an executable, and the name of the executable that we are going to generate is going to be move robot node. Yeah? And as you might be thinking, yes, this name that you give to the executable, of course, has to be the same one that you launch in your launch file. Yeah? And this executable is going to be generated from the following source file. Yeah, this move underscore robot CPP. Okay? Yeah? Then we are linking some dependencies. Yeah, so my executable is going to have the following dependencies: RCL CPP and geometry messages. Okay? Then I need to install the executable. Yeah, first. And also I am installing the launch folder. Okay? This is because ROS2 is not going to, of course, use this launch file or the executable from here. No, no. It's going to look for all these inside the install folder. After we compile, yeah, the executable is going to be added here, and also the launch file. And ROS2 is going to look for all of these here. Yeah, so we need to install the things that we are going to be using, which are the executable and the launch file. Okay? Then, now we are ready to compile. Okay? So, point number 5, let's go and compile. Yeah, always to compile, you have to be in the root of the workspace. Yeah? So to generate, to create new packages, it's inside the src of the folder. But to compile, you need to be in the root of the workspace, which is here. So let me copy this command. For commands, you can use this button. Okay, it doesn't matter. It's just for code that sometimes it doesn't work very well. But for commands, let me get this command and execute it here. Let me also get the second command, which is the callcom build. Yeah, callcom build is the command used for compiling in ROS2. Yeah, and then you specify with packages select the package that you want to compile. So let's compile our package here. Yeah, wait some seconds until it finishes compiling. It's almost done. There it goes. Okay. Great, so it has finished. Yeah, now after the compilation finishes, we are going to source our workspace. Yeah. And finally, we can execute our launch file. Yeah. So let's copy the final command with ROS2 launch. We specify the name of the package and the name of the launch file. Yeah. Our launch file, which is going to start the executable. Okay? So let's run this and let's have a look at the simulation to see what happens when I run my program. So let me come here, run my program, and have a look here at the simulation. And as you can see, the robot starts moving. Okay? Then, for instance, let's have a quick check here. So what happens now if I do a ROS2 topic info of command bell? Yeah? What are we going to see here? Let's have a look. So now, yeah, so the type is the same, of course. We can see the subscription. Yeah? We said before that the subscriber to the command bell topic is the robot itself, right? Or the simulation. Both are valid. But before, we didn't have any publisher, right? We had a 0 here. But now we have a 1, yeah? So who is this publisher? Of course, this publisher is us, yeah? So it's our program. Our program is the publisher of this command bell topic, right? Because we are publishing messages, yeah? Into this topic with our program. And another thing that you can check, which is very interesting, is the ROS2 topic echo command. Yeah? This echo command is going to allow you to read the messages that are being published into the command bell topic. Yeah? So if I execute this ROS2 topic echo command, I'm going to see which messages are being published into this topic. See? And here I can see all the messages that my program is publishing, which, if you remember, yeah, it was linear x 0.2 and angular z 0.2. Yeah? All right, so now what I'm going to do is to stop my program. Okay, let me stop it. And let me try to run again ROS2 topic info command bell. So my publisher now is back to 0. Why? Well, because I have stopped my program. So now nobody is publishing to the command bell topic. Okay? Now, there is an interesting thing here that you are going to see that even though you stop the program, the robot is going to keep moving, okay? Why? Well, this is because this topic is configured in order to keep listening to the last message that was published to the topic, yeah? Then, even though I am not publishing to the topic anymore, the topic is still using, let's say, the last message that I published before closing the program, okay? So, if you want to stop the robot, you have to publish a new message with the velocities to 0, yeah? So one option would be to change in the program here the velocities to 0, right? And recompile and run again the program, yeah? So then the robot would stop. But also, you can use a trick, yeah, which is to publish directly through the shell, okay? How can you do this? With this command that you have here in the notes, yeah? So let me copy this command and paste it here. See, ROS2 topic pub, okay? So we said that the ROS2 topic echo allows you to read the messages from a topic, from the command line. Yeah, it's the one that we were using here to visualize all the messages that were being published to the topic. Now, this new command, ROS2 topic pub, allows you to publish a message into a topic from the command line. Okay? So here we are going to publish one message, yeah, because we are indicating once, the once flag here. So I'm going to publish one single message to the command bell topic. Yeah, and this message is going to be a twist message with the following values. All the velocities to 0, right? Then let me open the simulation back again. So if I execute this command, once the message gets published to the topic, we are going to see how the robot stops. Okay? And of course, if you publish another message with velocities, let's put it to 0.1 and 0.1, the robot is going to start moving again. Okay? Let me stop it back. Yeah? Does it make sense? Yeah? Questions? Have you been able to run the demo of exercise 1? Yes, no? Yes, says Rick. Okay, perfect. Yeah, and did you understand how these topic publishers work? Yeah, at least a general picture. Hassan says yes. Okay. Also Rick. Perfect. Okay. Then let's move to the topic subscribers, okay? Because we are already out of time, but I would like to finish this. I think we can do it. Because the idea, the main idea, it's the same, okay? So yeah, so topic subscribers, of course, are the counterpart of the topic publisher. Yeah, the topic publisher, the publisher node, is used to publish data into a topic, and the subscriber node, as we said before, is used to read data from a topic. Okay. So we are going to do this exercise number 2, okay? I'm going to do it now myself, and you can review it later if you want. Yeah, you can try to do it. I'm going to go more or less fast on the different steps, but everything I'm going to be repeating same steps that I have done for the publisher. Okay, so nothing very difficult or hard to follow. So the first thing I'm going to do is to create a package. Okay, so let me come here where I wrote the command for the package. Here I have it, and then here I'm going to change the name of the package. First thing, topic subscriber package. Yeah, so instead of topic publisher package, I'm going to name it topic subscriber package. And then for the dependencies, I'm going to leave the first one, which is RCL CPP. Why? Because, well, I'm going to be creating C++ scripts, so I need it, yeah? But the geometry messages, do I really need it? Okay, how can I know this? Well, so let's keep reading the exercise here. It says, inside the topic subscriber package, create a new C++ script named sub-odom CPP. Inside the new script, create a subscriber node that subscribes and prints the odometry data of the robot. In particular, it will print the value of the X position of the robot. Then create a launch file named sub-odom launchpy, do the necessary modifications to CMake lists, compile and launch the program. Then here in the notes it says, the odometry of the robot is published by the robot into the odom topic. Yeah? So you will need to figure out what message uses the odom topic and the structure of this message. So how can I know this? Okay, I can use the commands that I have that I already know, right? Can Asman here? On launch file names, you should name them like I don't quite understand. So it shouldn't matter. Using the underscore or using the point shouldn't make a difference. The important thing is that it ends with .py. Okay, let's keep going. I can check this now with the new line file that we are going to create. Okay, so we can use a ROS2 topic list here, and we are going to see that we have this ODOM topic, right? Wait a second, I have lost. There we go. Yeah. Then how do I get information about this topic? ROS2 topic info. ODOM, right? Then this is telling me, okay, so the type of message that this uses is odometry message, which is defined in the nav messages package, right? So if I'm going to be working with odometry messages, what I want to add as dependency for my package is going to be nav messages, right? So let me come back here and add nav messages as a dependency for my new package. Yeah. Then I click enter and I generate the new package. Okay. Then okay. So here I still have the solution codes. So I'm going to get them from here. Okay. Then let me copy the code from here from the notebook. And then come to my code editor, and inside the topic subscriber package, inside the src folder, I'm going to create a new file named sub_odom cpp. And inside this cpp file, I'm going to paste the code. Okay? Now let's have a quick look here at the code. So again, I have the includes for RCL-CPP and the odometry message. In this case, I define a class which inherits from the node parent class, same as for the publisher. Then I have my constructor where I define the subscriber. Yeah. In this case, I use the create subscription method. Yeah. If you remember, for the publisher, it's create publisher. And as you can see, for the subscriber is create subscription. Okay? Then, of course, again, you have to specify the type of message that this node is going to subscribe to, which in this case, as we have already seen, is odometry from the nav messages package. Okay? Then I have to specify which topic I want to subscribe to, which is ODOM in this case. Yeah. And then here, this is also related to the quality of service, to the queue size in particular, so you can forget about this. And then finally here, I am binding a method, yeah, a method of the class, which is this ODOM callback. Yeah. So in the publisher example, I am creating a separate callback method, yeah, using a timer, as you can see. In the subscriber, I am binding this method directly to the subscriber. Why? Because subscribers, by definition, are going to have a callback method associated to it. Yeah? And so that every time that a new message is published into the topic, the callback method from the subscriber is going to be triggered, is going to be called, okay? So every time a new message is published to the ODOM topic, this ODOM callback method is going to be executed, okay? Then, of course, down here, I am implementing my ODOM callback method. Then this ODOM callback method, as you can see, is going to define a message containing the odometry. Yeah, well, actually it's a shared pointer, yeah, but it's going to receive a message containing the odometry, okay? Yeah, then inside this method, all, in this case, is super simple. All that I'm doing is to print a specific value from the message, which is this pose position X, okay? Then, how can you know all these variables? What is the structure? What is the definition of the odometry message? Well, we have already seen that also previously, right? It was with the ROS2 interface command. ROS2 interface show, yeah? And then you specify the package, the folder, his message, and then the name, which is odometry, yeah? And then I'm going to see the definition of the odometry message, yeah? You can see that this one is quite more complex, okay? So I'm not going to explain everything in detail, there's no time for that, but you can see that down here you have this pose, yeah, this first pose, which is a pose with covariance, the second pose, which is a regular pose, and then 2 points, a position point and an orientation quaternion, okay? And the position point contains X, Y, Z, and the quaternion for orientation contains also 4 floats in this case, which are X, Y, Z, and W. Okay, it also contains a covariance, but in this case, the value that we are accessing is pose position X. Yeah, so we are accessing this value here. Yeah, this X here, because we are going to pose, then pose again, then position, and then X. Yeah, and this is going to give me the position of the robot in the X axis. Yeah. So you can see here in the comment, estimated pose that is typically relative to a fixed world frame. Yeah. Okay. Now, yeah, then I define the subscription variable, and in the main function, I initiate the node and I spin the node. Yeah. So as you can see, it's pretty similar overall, the code to the publisher. But of course, it has some particularities, yeah, because we are not doing the same. It's not the same to publish to a topic than to subscribe to a topic. So, of course, there are some important things that are different, yeah? So, for instance, subscriptions are going to always have a callback method associated to it, okay? While publishers don't, yeah? If you want to create a method in order to create a loop for publishing messages continuously, then you're going to have to define a timer to do that, okay? All right, then, yeah, so let's well, we still have to create the launch file, right? So let me get it very quickly here from the notebook. Then let's create the launch folder here, and the launch file, which is sub_odom launch py. Okay, the launch file is exactly the same. Okay, the only thing that changes is the name of the package, of course, because it's a different package, and the name of the executable, because we are going to be because also the name of the executable is going to be different, right? And then last thing to do is to generate the executable by editing our CMake lists, okay? So here, in order to go faster, I'm going to copy here the structure from the publisher example, and then edit it for the subscriber. Yeah. So first thing is the name of my script is not move robot, right? Is sub_odom in this case, sub_odom. Yeah. Now the name of the executable, I'm going to name it in this case sub_odom_node. Okay. And the dependencies, I need to rename the node, the executable name here and here also. And then, of course, the dependency in this case is not geometry messages, right? It's nav messages. So I need to also update this. Yeah? And that's it. Okay, so I need to update the executable name. Remember that the executable name has to match the one that you put in the launch file. Okay, important. Of course, the name of the script is different because it's a completely different script. And the dependencies for my executable, also I have to update them. Yeah? And then I am installing this executable and the launch folder, which is the same. Okay? There we go. Then let's compile. Let's go to the root of the workspace. Colcon, build, packages, select, and topic subscriber package. There we go. Let's compile our new package. Okay, almost there. And there we go, okay? Now, after compilation, as we did before, remember to source the workspace. And now we can launch our node with the ROS2 launch command, specify the name of the package, which is topic subscriber package, and the name of the launch file, which is sub_odom.launch.py. Okay, let me run it, and then this is going to start subscribing to the Odom topic, of course, and printing the value of the X in this case. Okay, yeah. And that's all. So we are going to leave it. We are going to leave it here. Already 20 minutes past the expected time. So yeah, I know that maybe I've gone fast over some things. Yeah, but the time is very limited for these open classes. So I hope that at least you get an idea, more or less. And as always, you can keep practicing by your own. Okay. Later, so you're going to have this rosject forever, so you can keep practicing with it, doing your own tests, etc., etc. Yeah, and also, as always, let me remind you that you can learn much more, with much more details, examples, exercises in our course. Yeah, so we have just published it last week. You have the link here at the end of the notebook. We have published a new course on ROS2 basics, yeah, which is based on Galactic, and here you are going to find and be able to learn all the most basic topics and subjects related to ROS2. Yeah, so you have different units here. You have the unit for topics with everything that we have covered here, but with much more detail and many other things that we haven't done today because there's no time. You're going to learn about services, how to create services, how to create actions, debugging tools for ROS2, about node composition, and many things, okay? So if you are interested, give it a look. Give it a look because it's a very interesting course. I'm sure that you're going to love it. And yeah, as always, before finishing, let me activate very quickly the form so that you can rate today's open class. There we go. It should appear here in the chat in a few seconds. Okay. So that you can rate this open class if you liked it, if you found it useful, if not. Yeah, so that we can get some feedback and keep improving always. And yeah, so that's all. I'm going to leave it here. Thanks for being here with me during this hour and 20 minutes of today's open class, and I'm going to see you again next Tuesday with more ROS2. Okay, so next week we are going to come back with ROS2, but Python. Okay, so we are going to be using Python in next open class. So yeah, if you are interested, of course, I will wait you next Tuesday. And yeah, so thanks to everybody. And as always, take care and keep pushing your ROS learning. Bye bye.